Okay, we're live.
Oh, are we? Okay. Great. Let me welcome everyone to our beta talk for today, Secure Coding Practices for Front-End Developers. I quickly just want to say, just keep it, I'm going to keep it very short, but just about FETSA and what we do. And we'll post a few links. And then I'll quickly do an intro for Alicia, and then we'll hand it over to her, and she can say a little bit more about herself. So FITSA, we had a mental health in tech, and it was just front-end engineering South Africa, and there was ZAP that was product design. And at some point, we put our heads together. We thought, okay, let's just combine everything into one group. We're loving it at the moment. I think the brand and the look and the combined effort is really great. So the 4 pillars that we base all of this around is it all started with front-end engineering. Then there's the product design element to it. We've got mental health in tech and beginner support. Please check our LinkedIn pages and our meetup pages. We have quite a few events happening every week. And then at this point in time, we've got 2 main sponsors. One is called io.co.za, which is a product and startup builder, custom software type company. And then there's NML, which is a specialist financial services and software development company. Justin is head of front-end development and design. I hope I'm saying it the right way around. At NML. And then there's the email address here for anybody who's interested to get their company involved in sponsoring us. Everything everybody do at FETSA or does at FETSA is volunteer-based, using their own time. Nobody gets paid for anything. So any assistance there would be greatly appreciated. Then for today's talk with Alicia de Wet. Thank you, Alicia. It's greatly appreciated that you volunteered to do a talk for us. I'm going to leave. You can do your intro when I hand over. But Alicia is a front-end developer. She's very focused on accessible and secure applications. And then the talk for today is going to be around secure coding practices and the top 10 OWASP vulnerabilities. If you want to follow her or connect with her in any way, I don't know if it's readable, I'll just read it quickly. It's linkedin.com/in/Alicia-de-Wet. If you want to connect or chat to her or see what she's up to. And then just in terms of questions, if you make a comment on YouTube, we are able to see it on this end. If you make a comment on LinkedIn Live, if you're joining from there, we are also able to see it. It pulls through to us here in the little back office. We're going to leave the questions for the end of the talk today. But post them as you have them, and when they come up for yourself, we'll just sort of bank them and tackle them at the end. And then just to keep our community alive and to keep everyone informed and build our community, we have moved everything from Slack to Discord. We've got a really nice community going there. Started a bit from a fresh start for us. Justin will post the link to Discord for you in the chat. You should be able to see it. And then we also have a newsletter that you can subscribe to. And Justin will post the link for that as well. It's a monthly newsletter. There's some job posts, nice articles, and a few other bits and pieces, which is also growing nicely. So thank you for the people who have subscribed. And I think that's me. Justin, or Alicia, you can take over.
Cool. Thanks very much, Lisa. I appreciate it.
And yeah, welcome everyone. And I hope that I do not bore you to death today. But like Lisa said, my name is Alicia, and I'm a software engineer that is predominantly focused on front-end development. I currently live in the UK, but obviously grew up in South Africa, as I'm sure you can hear from my accent. And then on the front-end side of things, I most recently have been working with Vue, but I also have some experience working with React. So yeah, just to get started with secure coding for front-end developers. In today's web landscape, creating secure applications is of utmost importance as more and more of our lives move online. Sorry. We do banking, shopping, social media, calendars, conversations, work, everything's online. And as a front-end developer, you might think that the responsibility for creating secure applications lies solely with the backend team to create secure APIs and to ensure that data breaches don't happen. However, there are several things that front-end developers can and should be aware of and implement to improve an application's security, even before a request is processed by the API. So while backend security is essential, the front end of an application is actually the most exposed part. This is where we encourage user interaction by creating beautiful, performant, and smooth interfaces, where users can input data and interact with data. It is exactly here where developers need to focus on secure coding practices to prevent introducing vulnerabilities when data is collected, validated, and passed on to APIs. When an application's front end relies on users inputting sensitive data to interact with the application, a compromised front end has a direct impact on a user's security and trust. Data breaches resulting from compromised user data can lead to data theft and the exposure of sensitive user data. This, in turn, can lead to a business being fined and its reputation tarnished. The rise of SPAs, so single-page applications, and the increased complexity of modern web applications also pose a threat, as these applications handle more logic and data client-side, which increases the attack surface. Many of these applications also rely heavily on third-party scripts and packages, which aren't always secure. The goal of this talk is to help front-end developers understand that security can no longer be an afterthought for a front-end development team, and that front-end developers play a crucial part in safeguarding user data and trust. So by the end of the talk, I hope that you will have a better understanding of common secure coding practices and that you will feel empowered to implement these in projects you work on. So the first thing I want to touch on a little bit is the OWASP Top 10. The Open Web Application Security Project, or OWASP, is a non-profit foundation that works to improve the security of software. OWASP's mission is to make software security visible so that individuals and organizations can make informed decisions about software security risks. It is a global, open community that encourages participation and contribution, allowing the sharing of knowledge and expertise to happen freely. Apart from documentation, tools, standards, and guides that are provided on their website, the most well-known contribution from OWASP is the OWASP Top 10. This is a list of the 10 most critical web application security risks that is updated on a regular basis. This list serves as a valuable resource for developers, security professionals, and organizations. The OWASP Top 10 was first published in 2003 and was created due to the rapid growth of web applications and the increasing number of vulnerabilities that were detected. The need to create a standardized list of critical risks was identified and the OWASP Top 10 was born. Some of the key items from the OWASP Top 10 are injection, broken authentication, cross-site scripting, insecure design, vulnerable and outdated components, and CSRF, or cross-site request forgery. So the current 2021 list ranks the vulnerabilities as follows. So it's broken access control, cryptographic failures, injection, insecure design, security misconfiguration, vulnerable and outdated components, identification and authentication failures, software and data intake failures, security logging and monitoring failures, and server-side request forgery. The OWASP team are working on the newest update of the list, and that should be available, they said, by mid 2025. But today I'm going to talk a bit more about cross-site scripting, CSRF, so cross-site request forgery, and vulnerable and outdated components. So first on the list, as I said, is cross-site scripting. And I'm sure everyone has heard about it, but can you actually explain what it is? So cross-site scripting is a web security vulnerability that allows an attacker to inject malicious scripts into web pages. Attackers can exploit vulnerable websites that allow users supply data. They do this by injecting malicious scripts into vulnerable areas. These malicious scripts could then, for example, be executed in the browser when another user visits the page. There are three different types of cross-site scripting attacks: stored cross-site scripting, reflected cross-site scripting, and DOM-based cross-site scripting. So reflected attacks are those where the injected script is reflected off the web server, such as in an error message, search result, or any other response that includes some or all of the input sent to the server as part of the request. Reflected attacks are delivered to victims via another route, such as in an email message or on some other website. So when a user is tricked into clicking on a malicious link, submitting a specially crafted form, or even just browsing to a malicious site, the injection code travels to the vulnerable website, which reflects the attack back to the user's browser. The browser then executes the code because it came from a trusted server. Reflected cross-site scripting is also sometimes referred to as non-persistent or type 1 cross-site scripting. So stored attacks or stored cross-site scripting are those where the injected script is permanently stored on the target servers, such as in a database, in a message forum, visitor log, comment field, and the likes. The victim then retrieves the malicious script from the server where it requests the stored information. And the stored cross-site scripting is also sometimes referred to as persistent cross-site scripting. The last type, DOM-based cross-site scripting, is a cross-site scripting attack wherein the attack payload is executed as a result of modifying the DOM environment in the victim's browser used by the original client-side script, so that the client-side code runs in an unexpected manner. That is, the page itself does not change, but the client-side code contained in the page executes differently due to the malicious modifications that have occurred in the DOM environment. Reflected and stored cross-site scripting are server-side injection issues, while DOM-based cross-site scripting is a client-side injection issue. So with injected scripts, attackers can steal sensitive data or information such as cookies, session tokens, and even login credentials. They can redirect users to malicious sites. They can deface sites. They can even capture a user's keystrokes, all of which have rather nasty consequences. And these types of attacks are particularly dangerous since it can appear that the code comes from a trusted website, and users will often have no reason to suspect that anything is amiss. So common scenarios where cross-site scripting vulnerabilities can occur could include user input fields. And this is whenever an application includes user input without proper validation or escaping, whether from form fields, URL parameters, or any other input areas. Comments and messaging boards, where users are able to leave comments or post messages, and a website does not effectively sanitize the content before it is displayed to other users. Email and messaging systems, emails or messaging systems that are displaying messages that contain HTML. Search functions. An attacker could inject scripts through search queries if a search function reflects user input back to the browser without escaping it. URL manipulation. And this is where applications making use of URL parameters to modify the DOM, and they can be vulnerable then to DOM-based cross-site scripting events. Third-party widgets and plugins, including third-party widgets or plugins, can introduce cross-site scripting vulnerabilities. Rich content editors, applications allowing users to create rich content could inadvertently enable inserting malicious scripts. And then error messages, where improper error handling and allowing error messages that show user input, which then could lead to a site being exploited. So how are you able to mitigate cross-site scripting attacks. I'm briefly going to look at input validation, output encoding, content security policy, letting the framework do the work, and then also HTTP-only cookies. So the first and probably easiest step is to make sure that you have input validation enabled on all input fields, and that user input is also sanitized before you make use of it in the application. Thus, treat all user inputs as untrusted. Users are guilty until proven innocent. And some of the techniques that you can apply to validate user input include sanitizing the content by only allowing known safe characters or patterns, blocking known malicious characters, adding the appropriate input type. So for example, if you've got an input, set the type to email or to password or to number, for example. And also limiting the number of characters that a user can add to input fields. So where we need to look at kind of sanitizing input, this is a really simple example of a function where you would only allow alphanumeric characters and spaces. So next up, we can make use of output encoding or escaping user supplied data before displaying the data back in the browser. And this prevents the browser from interpreting it as executable code. And we can do this by replacing special characters with the HTML entity equivalents, encoding data used in URLs, and then encoding data used within JavaScript code. And a simple function to do encoding or to do encoding would then be something like this, where you've got again, sorry, you're just replacing the unsafe characters. And next up, we can define content security policy headers through content security policy through a header. And the headers are always set up server-side, or you can do that in a meta tag, which then tells the browser which sources of content are allowed to be loaded. And I'm giving you guys a list of all of the different values that can be set in the content security policy. So where we look at setting as having these set in the header, you'll see that the top example kind of shows what it would look like if you've got a CSP header set. And then the second example would be what you as frontend developer could then add to your index.html in the meta tag to make sure that you've got these set as well. So one of the benefits of using frameworks or libraries such as React or Vue or Angular is that they can, in some instances, automatically actually handle output encoding and other security measures. React, for example, automatically escapes JSX output. Angular provides built-in sanitization and security features, and Vue automatically escapes content when you use templates or render functions. I have a little demo app that I'm hoping to show you guys in a minute, and it took me a while this afternoon to try and force a simulated cross-site scripting attack with Vue, just because it actually handles a lot of this out of the box. So the last technique that I would like to quickly touch on that you can use to avoid, or at least try to avoid, cross-site scripting vulnerabilities in your application is the use of HTTP-only cookies. And this is also something that's set on the server side, but setting the HTTP-only flag on cookies will prevent client-side JavaScript from accessing them, which mitigates the impact of cross-site scripting attacks by preventing an attacker from stealing sensitive cookies. And the reason I think I'm telling you about HTTP-only cookies, the flags being set, and then also content security policy, is that one of the things that a front-end developer should do is have a look at responses received from the API and to actually make sure that these things are enabled. And to know enough that you can go to the backend team and say to them, you know, we need an HTTP only flag set, we need CSP set up, because this can actually lead to a vulnerable application. So if you bear with me, I'm going to see if I can actually get this demo up. Otherwise, I do have a backup, a video, but let's see if we can get this one up. Okay, I think, Justin, can you just confirm for me that it's showing?
It is here.
Okay, perfect. So what you'll see on screen is a very simple website at the top, and then at the bottom, I've got my terminal set up with a nice little PHP server just to be able to show you something in a minute. So initially, you can see that I've got an input, and I don't have, I'm not escaping the HTML output, so we should see what can happen. So I've got a little piece of code, and as soon as I paste it into this input, we should see an alert popping up, and that's exactly what happens. So I know that this input is a little tiny, but you can see there that we've got the alert code saying this is a cross-site scripting attack. As I mentioned earlier, you can also actually deface websites in a similar manner. So let's put in a little style tag, and we change the background to green. And just like that, it happened. We can also add a different type of background, which is just a fun little example. I was hoping this one's slightly bigger, but yeah, it says the image. You can see that the image has now been added, and these are ways of defacing websites. So the next thing I want to show is actually the importance of enabling the HTTP only cookie. So we can see that we've got a session cookie, a fake session cookie stored on this website, and we've got a session ID as the value in that. You can also see that the HTTP only flag has not been raised, so that's not applicable. Okay, so now I'm adding a little piece of script that says, do a fetch request to my attacker server and append the cookie value or the cookie to that. And then you can actually, so the attacker can actually then get a hold of that. So you can see here that the GET request was actually performed, and the session value or the cookie has been added. You can also see this in the network tab where we've got this where that was executed. So when we go back to this tab, or let's say I've now seen that we do not have an HTTP only cookie enabled, now go speak to the backend team, and now they've enabled the HTTP only cookie value. Let's keep an eye on the terminal at the bottom there. I made a mistake there, sorry. And you can see there that the request was fired off, but the cookie was not attached to that. And we can look at this in the network tab again as well, and it just has that. Perfect. Okay, now I need to switch screens again. Great. Okay, so it is important to note that the techniques that I've highlighted today are by no means the only techniques that you can apply. These are just a couple of examples that will already help you to create a more secure application. So the next type of attack that I would like to touch on today is cross-site request forgery, or CSRF. And CSRF occurs when an attacker tricks a user into performing unwanted actions on websites where they have been authenticated. So if we look at this diagram, imagine that we've got a user, and let's call her Alicia for today. So Alicia's logged into an internet banking account. The browser that is being used has stored the authentication cookies, so the bank knows that it is Alicia that is logged in. Now Alicia has received an email, a little spam email, to say there's a new online shop, and she's looking for a pretty new dress. She clicks on the link and she's visiting this online shopping website. But this website was actually created by a malicious attacker. And on this website, there's a hidden form with malicious code attached to it, designed to execute a request to the bank when the site is visited. So since Alicia is already logged into her bank account, the browser automatically attaches the authentication cookies to the request. And the bank receives a request to transfer money into the attacker's account. And because the cookies are valid, the bank assumes that the request is legitimate and actually transfers the money. So fortunately, there are a couple of ways in which a front-end developer can try to prevent CSRF attacks from being executed. So one way is to use synchronizer token pattern, or STP. And this technique involves the server generating a unique and unpredictable token for each user session. The token is then included in all forms and AJAX requests when the server receives the request, and it verifies that the token matches the one that is stored in the user session. And if the tokens do not match, the request is rejected. So the front end of an application should receive the token from the server and then include this as a hidden field in forms or as a custom header in AJAX requests. So if we add it as a header in a request, it should look something like this. So we've stored the CSRF token as a variable, and then that is attached to this header. Another way to guard against CSRF attacks is to make use of same-site cookies. So when adding the same-site attribute to a cookie, which tells the browser when to send a cookie with cross-site requests, there are 3 values that can be assigned to the attribute. That is strict, lax, or none. If the attribute is set to strict, the cookies are only sent when the request originates from the same site as the cookie itself. If the value is set to lax, cookies are sent with same site requests and top-level navigation, so GET requests from other sites. So this means that if a link to your bank appears on the malicious shopping website, the cookie will be sent. And if the value is set to none, the cookie is always sent. But when we're implementing same-site cookies, it is important to take note of the following things. So browser compatibility. Most modern browsers support same-site cookies, but older ones might not. So this cannot be your only solution when it comes to trying to avoid CSRF attacks. Server-side implementation. Front-end developers must communicate the need for the server to implement the correct same-site cookie policy, since it is set by the server when it sends the set cookie header. Secure attribute. When using same-site none, it is critical that the secure attribute is also added to ensure that the cookie is only sent over encrypted connections. And then also we need to look at the impact on cross-site functionality. If same-site is set to strict, for example, it can break some cross-site functionality, such as embedded content or third-party integrations. The last technique that I would like to mention today, and again, there are definitely more, but that is to make sure that the correct HTTP methods are used. So GET requests should only be used for safe operations, such as retrieving data. Post, put, and delete should be used for state-changing operations. And this helps to prevent CSRF attacks by ensuring that sensitive actions, such as state changes, can only be performed by requests that can be predicted by CSRF tokens. The last technique that I would like to mention today, and again, there are, oh, sorry, whoops, that's the wrong text. So the last thing I want to touch on is vulnerable and outdated components. And this simply means that you need to pay attention to the vulnerability log when you run, for example, npm install. Whenever you make use of libraries or packages in your projects that have known vulnerabilities, your application is an easy target for attackers, and they can easily exploit these vulnerabilities. But luckily, this is probably the easiest problem to solve. If you ensure that you are regularly updating all dependencies, things should be okay. And to keep on top of vulnerable dependencies, you can use dependency scanning tools such as npm audit or sneak, and monitor security advisories. Side note, for anyone using Next, update. Okay, so a couple of useful links that I've got here, but I'll probably share a couple with Liesl or Justin. They can also distribute it to the community. But OWASP has quite a few really nice resources. They've got a cheat sheet series that kind of looks at ways to see what is around and how you can mitigate them. And this is for front-end and back-end developers. The OWASP top 10 list, of course, and then there's another little HTML5 security cheat sheet that I've found quite useful. Okay, that is me. I'm happy to attempt to answer a couple of questions.
Great, thank you, Alicia. There are a few. First, a comment, just saying from Temiletu, just saying awesome. He fully agrees that we need to be writing safe and secure, not as an afterthought. So yeah, thanks for that. 2 questions from Sean. This one I think relates to when you went and defaced that site with the green background and the image and everything. Is it stored on the server? Is it permanent, in other words?
That can be permanent. I think it all of these kind of depend on how they're introduced to the website. So one of the examples that I've mentioned is when somebody adds something to a messaging board or a forum, then that can be something that's stored on the server. Because I think the example that, and it wasn't probably as clear because I know that the input was really small, but I added the malicious code or the script in an image tag, and that was executed when there was an error. So with the on error method on the image tag. So whenever that image isn't found or something's wrong with it, then that automatically will then be executed. So yeah, I mean, that can definitely be stored on the server.
Great, thank you. Question about SNCC. Can you integrate that with you when you're building, I presume locally, to do a check before you even send it off to a PR or something like that?
I would need to defer that. I haven't actually worked with SNCC before. I just know that it is one that's quite good.
Yeah.
But yeah, I think I would need to defer that to someone who's a bit more knowledgeable.
Yeah, we used to use SNCC, but now we use something else, so I can't speak to that one. Yeah. Are there any other questions from anyone on the streams? I have a few.
No, please
that I
don't.
just they're not allowed, don't worry. Just one around monitoring and maintenance. I know something like SNCC will do that for you. Sentry will do the same. Do you have any particular recommendations or how you continue to do that? Logging, patch management, etc., etc. Any thoughts on that?
I think it's, for me personally, so I've used Sentry quite a lot with work. So that's kind of probably something that if I change jobs or start a new project, then I'd implement that. But I think other than using SNCC or Sentry or something like that, I mean, every time you start up a project, you've got that little npm log, and it's so easy to ignore, but you need to get into the habit of actually looking at that.
It's very easy to ignore.
It is,
or just stick legacy peer deps on the end of your install, right? Yeah. Don't do that.
No. So yeah, I think it's just kind of keeping on top of stuff, making sure that you signed on to newsletters and things that actually show you what vulnerabilities have been found, keeping on top of things like that. I know GitHub also, for my personal projects that I've got on GitHub, I often get emails going, you need to look at this package and this thing. So again, don't just delete them, update them. And also update them. Sorry,
go ahead.
I think also just update as often as possible, not just for vulnerabilities, but I've had projects where you need to go from a relatively legacy code base to something new, and what should have been a 10 or 15 minute quick update of a couple of packages ended up being a couple of days or even weeks worth of refactoring, and just it's a mess.
Yeah, absolutely agree with that. The GitHub one is the Dependabot, they call it.
Yes. Yes.
You get your weekly email on all your repos for any. But yeah, what they do nicely is if possible, they just create an automatic PR for you, which is great.
Yes.
Yeah, so definitely don't ignore those. Most of the time, it's literally just going and approving something they've already done for you.
Yeah, exactly.
There's a question from Bayers on Angular versus Vue versus React. Which one is best for sanitation? Sure.
I don't know. I'm not all of them.
I think
I
you're
honestly
right.
don't know. I honestly don't know. It's like I was saying earlier. I thought it was going to be really easy to kind of trigger some of these things that I was showing you guys in the demo, but Vue absolutely did not allow me to add script tags. It completely ignored that. So I haven't forced React to do the same. So, but I mean, they already do output encoding. So I don't think that one is necessarily better than the other. So I think as long as you kind of don't circumvent that and don't go around the measures that these frameworks have set in place, then you should be relatively okay.
Yeah. I mean, I can speak on behalf of React because we work a lot with React and Next, and you've got to try really, really hard to, as you say, make it do things it doesn't want you to do. So there's very good sanitation like that with JSX just automatically escaping things, of course, React does have dangerously set inner HTML. I'm not sure if Vue has something similar. If you're using that, it's bypassing default escaping. Just something to bear in mind.
So even with that, so Vue has the vHTML, and that's how I triggered these things this afternoon, or these actions this afternoon. But even with that, like I said earlier, it ignored anything that said script tag.
Right. Okay. Good to know. Yeah. I cannot speak about Angular at all. I have no idea.
I worked with Angular years and years and years ago.
I think we just have some additional comments from Duncan saying thank you. It was very interesting, and you'll watch again later because he's on his phone. But I think also raises a good point here because it would be useful for testing.
Definitely.
So I'm not sure what your QA processes are in your current workflow, but does your do you have a QA team that does any security testing, or is it outsourced? Or?
So we have a QA team, but they don't necessarily focus on security testing. But we did have a company come in to do some vulnerability testing and scanning. It was relatively high level, but I mean, still there things came out that we honestly hadn't paid attention to and thought about. And it's super important to just have that every now and again, just as a reminder to say, still need to look at this.
Yeah, I mean, I can speak from my experience as well. We also outsource to companies who their main job is to get into your application in some way and make it break. And there are always things you've overlooked. Yeah. And it's quite terrifying watching them as well.
It is.
But yeah. Content security policies. Just a quick question for you on that one. They can lead you to tear your hair out sometimes because you're trying to have the strictest policy as possible and it keeps breaking things. Do you have any kind of tips for that, or is it just trial and error largely?
Honestly, for me, it's just trial and error. Figure out what it is that works, what combination you need to do, and kind of hope for the best, I suppose. I know hope is not a strategy, but
Yeah, no, I understand. That's my experience tracks exactly with that. Yeah, and sometimes there are things you have to kind of let slip through. Frame ancestors and things like that can be really tricky. API routes and secrets. Do you have any kind of thoughts on that? And storing your secrets and I mean, we would do things mostly in Next, and you've got an end file there. Next is going to just expose that. So have we lost Alicia Liesel? No. Oh, sorry. I thought you froze that for a second.
Yeah, I think when it comes to secrets, I mean, golden rules always never store secrets publicly. Use environment files and environment variables wherever possible. I know that we've got a pipeline set up on Bitbucket, and that's where the variables live. So I think that's probably just always be aware. Don't push that up to GitHub or to Bitbucket in your repo, because that is a vulnerable source or vulnerable point.
Yeah, there's always these occasional blog posts on someone who's just gone and done a search for secrets on GitHub repos and come back with thousands of results.
Yeah.
So, yeah, do not do that.
Also, don't share your SSH keys.
Oh, no, never. and make the password when you create them. Just skip that bit. Yeah, great. Well, thanks so much, Alicia. I don't think there are any other questions. Liesel, unless you have anything.
Nothing from my side.
I just want to say this was a particularly well-timed talk. Any of us who work in the Next.js world might know that on Saturday, Next released a critical update for cross-site scripting attacks that could bypass your auth in all versions of Next from 12 right up to the latest. So yeah, my day was scrambling around getting all our 5 projects that use Next to patch all of those things. So yeah, just to reiterate what you've been saying, how important it is to keep an eye on these things. And funnily enough, I wouldn't have known about that unless I subscribed to the Vercel blog newsletter, because it's not like they're going to send out something to you to tell you, hey, update this. Yeah, you've got to be keeping your eye on those things all the time to mitigate these kinds of problems. So very, very well timed.
Absolutely.
Yeah.
Awesome.
Okay. All right.
Well, thank you so much.
Thanks.
Thank you, Alicia. Thanks again.
Thanks
Pleasure.
to everyone who joined and for the questions. And yeah, our Discord link is there near the beginning of the chat, and our newsletter. Please have a look at those, and yeah, join us for some lively discussions.
Yes, and then we will post the recording when it's ready.
Yes. Yeah.
For Duncan and Co, who's going to watch it later.
Yeah.
Thanks.
Great. Yeah, it'll be on our YouTube indefinitely, and we'll also post the links on our Discord. Great.
Cool.
Thank you.